What burns better, marshmallows or magnesium? Well, it's a pity when your perfectly golden toasted marshmallow suddenly combusts into flame over a fire. The burning of magnesium tends to elicit thrill as we enjoy a good fireworks show. But why do marshmallows and magnesium burn so differently? Marshmallows burn slow and soft, while the magnesium in fireworks burns fast and bright. The answer comes down to the difference in chemical properties between marshmallows and magnesium. A chemical property is a quality of a substance that can only be observed when that substance is undergoing a chemical change. What is changing exactly? It's the molecular composition of the substance. If the molecules change into other molecules, then we have a chemical change. A chemical change is also known as a chemical reaction. It's important to know, however, that chemical properties can only be observed either during or after a chemical change. There's no way to really look at a substance and identify its chemical properties. We have to see the object undergo a chemical change to learn about its chemical properties. So, what are some common examples of chemical properties? You may have heard of a few. They include flammability, the eagerness of a substance to burn or ignite; toxicity, the eagerness of a substance to damage an organism's tissue; radioactivity, the eagerness of a substance to emit radiation; chemical stability, the eagerness of a substance to react with its environment. As you can see, chemical properties are a quality that can only be determined upon changing a substance's chemical identity. They are not chemical changes themselves, just the events we can see during the reaction. While chemical properties and chemical changes are linked concepts, it is important to note their distinction. Now, let's take a closer look at chemical changes. When a chemical change occurs, the molecules of the original substance are changed into molecules of a different substance. When your marshmallow catches fire in the woods, molecules of sugar undergo a reaction, that is, a chemical change. They change into molecules of gas, water, and ash. The carbon that used to be part of the sucrose sugar molecules now makes up the hot gases and ash. There are certainly other elements involved, such as hydrogen and oxygen, but that requires a deeper understanding of reaction chemistry for another time. So why does magnesium burn more brilliantly than a marshmallow? That's because a chemical property called the heat of formation has a far greater magnitude for the products formed from burning magnesium than from burning marshmallows. And the more heat, the more light. Of course, this might also be why we get distracted and burn our marshmallows while watching burning magnesium fly across the sky on the 4th of July.